That's good. Go on.
Okay, Teju, shall we start now?
Yes.
The topic is
Physics. Oh wait, law of motion.
laws of motion. Laws of motion.
Motion.
So here also, like chemistry previous topic, here also there are three laws. There are three laws
Three laws.
of
Three
motion.
laws of motion.
The previous chemistry also, there are three states of matter. In the same way, today in physics also, there are three laws. So today, our lucky number is 3 in both the physics and chemistry. Okay. So here, three laws of motion. Who gave
Okay.
these laws of motion? Can you able to say? Who proposed or who gave these laws of motion? The scientist name I want. Can you able to say the name of the scientist? Shall I write the first letter?
Newton's law?
Yeah. The name of the scientist is
Newton.
Newton. Isn't it or not?
Yes.
So before that, first of all, a small physics word we have to learn. That is force. That is
Okay.
force. So entire chapter is related with force only. This laws of motion, entire chapter is related with force. Without force, we can't do anything. Isn't it or not? Without force,
that's
we can't do anything. So for example, now I am holding my mobile in my hand. I'm holding my mobile in my hand and I'm pulling my mobile or pushing my mobile according to the sequence of the paper or book, so that you are easily seeing or it can be visible for you very easily and very brightly. I'm pulling and pushing. See the movement. See, it is wavering from one place to another place. It is waving. So with some force, I am pushing or pulling my mobile so that it is moving from my hand to one place to another place like this. Isn't it or not?
Yes.
So according to force, the formula is force is equal to capital F is equal to M into A, M-A, M into A, where M is mass.
M is mass.
Mass of an object and A is acceleration of an object.
Okay.
A is acceleration of
an object.
The product of mass and acceleration is nothing but force. Okay.
Okay, sure. Okay, sir.
Now, so this F is equal to ma. This F is equal to ma. This is Newton's second law.
Okay, sir.
This is
Newton's second law. Second law.
So then you may ask, sir, what sir, without completing the first law, you are entering into second law. What about the first law, sir? First law is very easy law that every body, first law I am telling now. First law I am writing. First law is every body continues to be state of rest.
State of
rest.
Okay.
Or
is that
uniform motion, or of uniform motion.
Uniform motion.
Unless.
Wait. Uniform motion unless
an external force.
An external force.
An external force.
Okay.
Should act on it.
Oh, it's not course, right? It's force. Okay.
Yeah. An external force should act on it.
Act on it. Okay.
So what is the meaning of it? What's the meaning behind this Newton's first law? The meaning is, for example, you are sitting under the fan, I think so. Okay, in your house, at present you are sitting under the fan. isn't it?
Yes.
So fan is rotating.
Yes.
At present, fan is rotating.
Yeah.
In your room, in your bedroom, or in your any front room or drawing room. At present, happily you are sitting under the fan and you are listening my topic, and on the top your fan is rotating.
Yes.
Up to what extent the fan will rotate? Can you able to say up to what extent? Up to how much time the fan will rotate?
It can rotate anything, like anytime.
Up to how much? Up to how much time? Can you able to say? There
No,
are two
sir.
possibilities. There are two possibilities that if you want to stop it. The first possibility, you have to switch off the fan. You have to switch off.
Switch off the fan.
Or else the power should go. Isn't it? Or
Oh,
else the
okay.
entire power should go. Until these two, if you leave the fan like that for days, weeks, months, years, it will rotate. Isn't it or not?
Yeah, because
Yeah,
it can rotate without any of those possibilities.
That is the first law given by the Newton. If
Yes.
anybody wants to stop, or if anybody wants to start, an external force should apply on it. Now
Okay.
you have to walk from your bed or from your table or from your study room or from your study bed to the switchboard, and you are supposed to switch off the fan, switch off the switch near the switchboard. Automatically the fan will come to rest. So
Okay.
until an external force, it won't go. For example, you kept your pen, pad, book after this class and you went from your study room. That pen, pad, book, all the three items or three objects will be there forever and ever unless your mom or servant maid or your father will come and they will replace from the position. Isn't it or not?
Yes.
Up to 1 hour or 1 week or 10 days or 1 month also. In the same place, your three items. What are the three items? Pen, book, and pad.
Yes.
All the three items will be there forever and ever. Unless an external with some force, they have to lift it, they have to carry it, they have to take it from that position, and again they have to keep it in the wardrobe or shelf or almirah. Until that, those will be there. That is the Newton given law, the first law given by the Isaac Newton. And the second law is, as we first initially I told, F is equal to ma. So force is always equals to product of mass and acceleration. So before going there, I have to tell initial velocity. Initial velocity. It is always represented by small u. Initial velocity. Initial means starting. Initial means starting. Okay. Next. Final velocity. Final velocity. It is denoted by letter V, small v. Initial velocity.
Wait, after initial velocity, what do you write for it? Is that A?
INITIAL, initial velocity. It is denoted by letter U, small u.
Okay, U.
U. Final velocity.
Final
Velocity.
Final velocity
Is denoted by small v.
V. Okay.
V. Now, V, change in velocity next.
V?
Change in velocity.
Engine velocity, right?
Change in velocity.
Oh. Change
in velocity.
In velocity.
Change in velocity.
In velocity, okay.
Yeah. What is the change? V minus U, isn't it? For example.
V minus U. Yeah. Oh, yeah.
Yeah. For example, you have 5 rupees. Okay.
Yeah.
And your sister had 2 rupees with her.
Okay.
What is the change in between you and your sister? Difference. Change means difference. How much difference? In your pocket, you are having 5 rupee coin, and in your sister pocket, she is having 2 rupee coin. What is the change of amount in between you both?
3 rupees.
How you got the 3? Because
I
highest amount 5 minus pi minus
Yeah.
q. Isn't it or not?
Yeah.
In the same way, change in velocity means final velocity minus initial velocity. Okay.
Initial
Change in
velocity.
velocity means final velocity minus
Minus.
initial velocity. V minus
Okay.
u. Okay.
Okay.
So V minus u is always equals to AT.
AB.
B AT. A into T. AT means.
Oh, 80.
What is A here? Already we discussed what is A here.
Is accelerating.
Yeah,
Acceleration.
so the same here also. A means
Acceleration.
acceleration. Okay, and T means
Temperature.
T. Time. T
Oh,
means
okay. Time.
time. So V minus U is equal to A into T.
A into T.
Okay,
80.
AT. Very good. Very good. Or it also can be written as V minus U by T is equal to A. Is it correct or wrong?
Yes.
Yes. Is it right?
Yes.
Because here A and T are doing multiplication. Both are multiplying each other.
Yeah, I know.
So as
I
soon
know.
as this is the minimum this one terminology. V minus U by T is equal to A. This is one and foremost equation, very important equation. Okay. V minus U is by T is equal to A. And coming to the Newton's
Third law.
third law. So everyone knows that Newton's third law, isn't it or not? What is Newton's third law?
I don't know, sir.
No, you don't know?
No.
Yeah, I will tell. To every action,
Okay.
to every
To
action,
every action.
there
Okay.
is
Yeah, there is
equal and opposite
and opposite. Yeah.
reaction.
Reaction.
Okay. So
Okay.
to every action, there is equal and opposite reaction. For example, at present in your school, while at the time of the school days, you are sitting on the bench and you are listening what the teacher is explaining the lesson, and your friend beside of you, who sat beside of you, is pulling your pen from your hand. Pulling your pen from your hand. So the pulling of the pen from your hand is action.
Okay.
Okay, while very keenly, very interesting topic your teacher is explaining, and you are looking at the board with 100% of concentration, but beside the friend who sat beside of you, the friend, your friend, best friend, is pulling the pen or pencil from your hand and disturbing you. So pulling the pencil or pen is an action by your friend. Then
Yes.
obviously, what is the reaction? There are two types of reactions from
You
your
would
side.
want to get it back.
Yeah, one, complain to your teacher. I'm shouting and complaining to teacher. This fellow is pinching me or pulling my pen. Some complaint. That is your reaction. Or simply you will scold or hit him, and you want to react from your side. That is also second reaction, isn't it? All?
Yes.
Yes, because here to every action, for example, you forced a ball towards the wall. You forced it. You throw the ball towards the wall. Then throwing the ball is action, and again bouncing back towards you is reaction. Isn't it?
Okay. Is it? Yes, it is.
And
Yes.
one more example. Okay, you are firing the gun. So the trigger is there. You pricked the trigger. Automatically, what is the action? Action is the bullet emitted from the gun towards the opposite direction. That is action. And the gun bouncing back towards you. That is reaction.
Okay.
And simple example, your walking style. Your walking style is a Newton's third law. Or take it all these examples, daily activity example. Your only walking style is only the Newton's third law.
Okay.
Okay, how? Because while you are walking,
Because
if you are putting the front leg, the right leg front, obviously your left leg will back, isn't it? All?
Yeah. Because
While
you
you're
can
walking,
walk with one leg.
Yeah, while you're walking, for example, you are putting your right leg forward means obviously your left leg will be back. Again, if you are putting the left leg forward means again your right leg will be back. So the walking style in your daily activity is also one of the best example of Newton's third law.
Third law.
Now, a small numerical way. I'm turning the page. Now, calculate
Yes.
Calculate the acceleration
Yes.
for a force of, what are the units of force?
For a
Newton. What are the units of force?
For a force of
Newton. The units of force is Newton.
Wait. Okay.
Calculate the acceleration for a force of 5 newtons. Of 5 newtons.
Of 5 newtons. Okay. Yes.
Having mass 5 kg.
5 kg. Okay. Okay.
5 kg. Okay. So what he's asking? What to find out?
Calculate the acceleration for a force of 5 newtons having mass 5 kgs.
Yeah. What is asking? What to find out?
The acceleration.
Very good. Acceleration. What are the given things? Force given. Isn't it or not?
Yes.
Force how much? Force. How much he has given in the
Force
problem?
is 5 newtons.
Very good. And mass?
Mass is 5 kgs.
5 kg. What is the formula required here according to Newton's second law? According to Newton's second law.
Force equals to mass.
M into?
Right? Mass acceleration.
Acceleration, exactly. Now,
so that means F by A.
F means what?
F by A equals to mass.
F by.
Oh wait, sorry.
M.
So you want
F
acceleration, right? So F by M equals to acceleration.
Very good. Acceleration. Very good. So what is F here? 5. By what is mass here?
5 by 5.
Yeah.
Equals to acceleration, which is also called as 1 by equals to A.
A is equal to 1.
A
is equal to 1.
Acceleration.
So the very good. The units of acceleration is meters per second square. Meters per second square.
Second square.
Yeah.
Meters
per second square. Slash per means slash. Slash second square. Okay.
Second square. Okay.
So this is the value of acceleration.
Okay.
This is the value of acceleration. One more problem. Yeah, one more problem I'm giving. You are supposed to tell the answer. Is it clear?
Okay.
Shall we start?
Yes.
Very good. Very good. 1 second. 1 second. Write down. Calculate. I'm dictating. Calculate the mass. If, if the force applied is.
If the force
applied. If the force applied is the force applied is
10 newtons.
With an acceleration of 2 meters per second square.
2 meters per second. Oh wait, per second square. Okay, I will.
Can you able to solve it?
Yes.
Can you able to solve it? The same formula. F is equal to mA.
So force equals to 10 newtons, right? So then obviously acceleration would be 2 meters per second. I'm just writing.
We have to find out mass.
And I have to find out mass. So wait, so 10 by, okay, no. Okay. M equals to force into acceleration, right?
Yeah. What?
Force, M equals to force into acceleration.
No. Force by acceleration.
Force by acceleration. So yeah. I'll do this. M equals to force by acceleration. That means you want the mass. So force equals to
10.
Force equals to 10. Okay. Oh, mass equals to 5.
What 5 units? What
yeah,
units?
5 units. Okay, 5 units.
5 what units? Kg.
5 units.
5
kg.
Yeah. So is it clear how to solve the problem?
Yes, sir.
Okay, so entire the concept is F is equal to mA. And tomorrow we are going to enter into the deep formulas. Some 3 internal formulas are there related to U, V, S and T. S